Okay, in the last video, we looked at StarCoder and we looked at the concept of generating code or using it, that kind of thing, asking questions, coding questions with StarChat Alpha, etc. In this video, I want to look at, can we use this model or one of these models for actually doing reasoning tasks? So doing things like PAL, the program-aided language model stuff. And that's basically where we ask it a question in English, and to really answer that and do the reasoning over that question, it then needs to write out a function. And it will write that function out in Python, and then it will evaluate that function and see, okay, does that give the right answer or not? So it turns out that Hugging Face has actually made a demo for this. So they're calling this reasoning with StarCoder. They've been a little bit not helpful in that we couldn't see what model they were using. So when we go to see what model they're using, it actually doesn't show up. But after testing a number of the models, I think they're just using the base model for this. And the idea here is that you pick one of the strategies. We're going to pick PAL for this. And you can see that we put in a query in English. So if we come down to some of the examples, we can pick one of the PAL ones. And then we will just click submit. And it will basically take the English query and then write that as a Python function and then process that. So you can see here, we've just got, a function being called solution. It's got the English query inside. It's then writing out the code for that. And then it basically processes this. Exactly the same as the PAL chain in LangChain, which I've already made a video about. If you haven't watched that, go and have a look at that. So the concept of PAL is really amazing. The challenge has always been that we often need to use a very big model to get it to work. And one of the more recent challenges is the model that people were using was one of the OpenAI Codex models, which they've actually deprecated. They've taken down that model now. They're no longer serving that. So they're trying to push people to use the GPT 3.5 models and perhaps in the future GPT-4 model for it. But it would be very nice to be able to have our own non-OpenAI model that we could use for this kind of thing. So this is where, looking at StarCoder comes in. So they've got a few of these in here. If we have a look at one of the other ones. So the question here is basically write a program to filter all the odd numbers from a Python list. And we can see that, okay, here it's basically just written a program to do that. And sure enough, we've got our odd numbers in there. If we look at some of the other ones, what's another one that they've got here? Okay, so dealing with dimensions. The dimensions of input image are 80 by 80. Let's look at this. And we can see, sure enough, it basically writes the code to get us a solution out for this. And this makes sense that we would lose a pixel on each side of the image if we were running a 3x3 convolution across the top of the image there. Okay, so let's try out some other ones that are perhaps not what they've got there. Okay, so if we put in one of the examples from the Plan T5 paper, we can see here that, okay, we've asked it, answer the following question reasoning step by step. The cafeteria had 23 apples. They used 20. They got 6 more. They should have 9 left. And sure enough, the answer is 9. Let's try another one. Okay, for this one, Roger has 5 tennis balls. He buys 2 cans of tennis balls. Each can has 3 tennis balls. So that should be 2 by 3 is 6 plus 5. Let's see, can this get 11? And we see it didn't do a great job on this one. It seems to have got, quite some of the things together, but then the final sort of putting it all together, it's done not a great job there for doing that. So already we can see that perhaps the reasoning on this one is not that great, but let's see how we could replicate this in code. And then let's see, will this actually interface with the LangChain PAL chain for doing this? Okay, so if we come in here and look at the prompt that they're using, we can see that basically they're putting in a def solution and then the question, and then it will write the rest of the function for this. So we can see that they've got 1, 2, 3, 4 examples, and then they prompt it for an output out there. So let's go over to code and look at how we can recreate this in code. Okay, in this notebook, we're going to look at, can we reproduce the reasoning from the Hugging Face spaces. But more than that, can we actually perhaps improve on it? Can we get it to work with LangChain in here? So like I said, it was a little bit vague as to what model they're using. I've tried out a few different models. In the end, I'm going with this StarCoder base model. So it's an interesting observation that when people do instruct fine tuning on these models, they tend to lose some of their raw reasoning power that's not in that fine tuning. Now, if it's in that fine tuning, it will be reinforced and it will be really good. But if it's not in that fine tuning, they tend to lose it. So when I tried this with the StarChat Alpha, I didn't get good results at all. Every answer was wrong. When I tried it with the StarCoder, just not the base one, but the one that they've fine tuned, also didn't get very good results with that at all. So here I've gone for the StarCoder base. You will need to come in here and accept the terms to be able to download this. And then I'm just setting it up like a normal large language model. Now you will need to set up the Hugging Face Hub import here. And then we're going to bring it in. I'm going to bring it in as 8-bit. And you will need to pass in this authentication token because it needs to know that you've accepted the terms on the service. Once we bring it in, we then need to set it up. I'm just going to add in the end of sentence token to be the padding token as well in here. And then we've got prompts. And I've got a bunch of different prompts. So I've put all my prompts at the top. But you'll see me come back to these throughout the video. Then just to show you what we're actually doing. So remember that this is not a fine-tuned model, right? This is the raw model. So with raw models, we tend to want to have really much longer prompts with lots of in-context learning for it. So it gives it a chance to basically learn this. Now, I did try, if you want to actually try the StarCoder model, they have that up here as an API that you can ping. Unfortunately for me, it worked in getting results from the API, but those results weren't very good for the PAL stuff at all. So I basically got a generation function, and then I've got some pre-processing and post-processing functions. So these are basically just to, one, add in the actual prompt that we're going to be using. So the first one I'm going to use is just called the prompt. So let's actually have a quick look at that up here. Okay. So this is the prompt. You can see that basically it's just doing in-context learning where it's passing in 1, 2, 3, 4 examples, and then it will generate an example. Now, already I can see that this is going to cause problems for LangChain. In LangChain, with the PAL prompt there, we pass in the question and it writes the def solution itself. Here, we're basically passing in the start of the function and then the question as a commented out comment, and then it will write the rest of the function in here. I don't know why they chose this to be like this. If we look at the actual PAL math prompts from the paper, we can see that this is how they've done it. We've got question, solution in Python, some new line characters, and then the function. This is what LangChain uses for this. So already I can see that this is probably going to have some issues with LangChain going through it. But coming back, let's just have a look at going through this now with this basic prompt. So this is the same prompt that they're using on the spaces part there. All right, so we've then got, once it returns back, we basically filter out the end of text things. Also, I was finding that it would often generate like a Jupyter tags in there. So I'm just filtering out those as well to get it, and then we're printing it out. So I've put in a few example questions in here, some of the ones from the actual Hugging Face spaces, and then also some other ones from various places that I know can be answered by PAL with the old codex model. All right, so first off, we can see that if we generate the first question and we basically pass this in, we get back a function, and it looks like this is reasonably good. So I've just copied this in and pasted it in here. Now I need to import math. Unfortunately, it didn't put that in, but once I've got that in, actually it works, right? And we can see that, okay, this is working for this. So when we look at the second one, it is write a program to filter all the odd numbers from a Python list. You can see this is the list that it generated. It's basically written the program to do that. If we run that program, sure enough, it's taken out the even numbers there and just left the odd numbers in there. Here's one that didn't work. So this was the passing a 3x3 filter over an image. This was working earlier on, so it could just be that sometimes it works and sometimes it doesn't work for this one. But this one clearly didn't work because it basically used the variable stride and it hadn't defined it anywhere in there. We can also see that there's some weird stuff going on there with the formatting too. The formatting is not looking as good as perhaps we would want there. Next one up is the question about the apples. So this one we've used in a lot of videos. Answer the following by reasoning step by step. Cafeteria has had 23 apples. If they used 20 for lunch and bought 6 more, how many apples do they have left? The answer should be 9, but it's not, right? What they've basically got here is producing 3. So it's gotten the variables right, that the apple count at the start's 23, you minus 20, that should leave you 3 over, and then you buy 6 more, which gives you 9. But then this part here, they've messed up for this. So that's one that they've messed up. Another one, and I've tried this one also. So some of these also don't often work in the Hugging Face spaces as well. Sometimes they do, sometimes they don't for some of these. Another one was this one. So this is basically Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3 tennis balls. How many tennis balls does he have? Right. So it's basically 2 times 3 plus 5. It should be 11. We can see that it's really gone off here. It's not what we want here. And we can see that sure enough, it's even asking us to input, the things in here. It actually wants us to input the number of tennis balls in there. So that hasn't done a good job. And this is because we've used the prompt with only 4 examples. So let me go through and run them now on a prompt where we've got more examples. So rather than 4, this time I'm going to pass in 8, and we'll look at the responses from the 8 when I come back. Okay, so before we were using a prompt that had 4 examples, 4 in-context learning examples in it. I've now moved to one that has 8 in this. And you can play around with these prompts. I've actually got a few different ones in here that I tried for doing this. But when we've got a context size of 8,000 tokens, we might as well put in a lot of in-context learning. So I'd even be tempted to do versions of this where you've got 10, 15 plus examples in the actual in-context learning for doing this. Let's go and look at the results and see what changed. So the only thing I need to change in the code here is I need to basically tell it to use the long prompt this time rather than just prompt in there. I'm going through the same questions. So the first one, it does well, gets that one right like before. Second one gets that right. Third gets that one right. Interestingly, up here, it actually runs the function twice. It comes out and runs the function twice, but I'd still consider that one right. The next one, unfortunately, still not correct, although the answer seems to be more interesting now, in that now it seems to have really understood that, okay, it needs to have a stride variable in there, but it adds in this padding equals valid, which is the kind of thing you would add to, a Keras convolution layer, that kind of thing, or even a PyTorch layer. And you can see that because that's a string, that causes us to have this error here. The rest of it, it's pretty interesting, how it's done it. Next one. So this one was wrong before, the one about the apples. This time it gets it right. So this time it actually works out that, okay, it should start off with 23. It should have the 23 plus whatever you bought minus whatever you used. It's going to leave 9 there. So that one worked. And then this one for the long one, sometimes it works, sometimes it doesn't work. In this case, it didn't work. It was probably better than before in that it didn't try to get us to input any numbers or anything like that. And it certainly worked out that this is a can, is 2 cans, each can has 3 in it. So it's worked out a lot of the reasoning parts to this, but then putting it together, it hasn't done a good job. So here we can see that it's basically falling down here of where it, rather than just do number of cans times number of balls in each can, it's subtracting how many balls he had at the start, which is clearly wrong there. So I'd encourage you to go through and play with the prompts yourself. If you make them longer, you may be able to get it to work. The fundamental problem, though, that we're going to have with LangChain. So let me walk you through how we can test this out in LangChain. So to test this model out in LangChain, we basically need to bring it in. We need to create a Hugging Face pipeline and then use that as a local LLM for LangChain. And then we can bring it in to actually do the testing. So I'm also going to put in just a little callback function on this so that we can actually see what is going in, what is coming out of the language model before any pre-processing that is done by the chain or anything like that. We then define the PAL chain and we then give it some questions. So the first one is a question that they all got wrong. And sure enough, this one also got it wrong in there. So this is an interesting one where you've got to multiply and then you've got to add to a variable as well. This is the kind of thing, though, that the OpenAI model would get it quite easily for that. But so far, this model hasn't, been able to do that. So you can see that as I'm basically printing out what we're passing in at the start is basically a very long prompt that's going in for this. Now, you'll notice that this prompt is different than what we were using up above, because this is the natural LangChain PAL prompt. This is how it's laid out, is that you basically pass in a question, you say solution in Python, it will give you a solution to this. So it's actually quite different than the way the StarCoder reasoning PAL is done in their one. So sure enough, it doesn't work at all, right? In fact, it doesn't even produce any output. We can see here, I basically put stop after the output, and you can see there's nothing, coming out from this. So it's not getting anything that's going on in there. Okay, if we give it some of the other questions. So one of the questions just about the radians, sine of 30, solution, you can see it hasn't given us anything back in there. So this model's not playing nicely with LangChain at all. So, okay, we can see that that's the prompt there. So the obvious thing then is to try and take one of the prompts that we know was working for quite a few of the questions up above and use that. So I basically put in the long prompt, and I've tried out a few long prompts to try and manipulate these, and then passing this in. Now, this gets us further than we got before, in that we now can see that it's starting to generate actual code out for each of these things, but it's still not code that can be run. So it shows us that, okay, the problem with the way StarCoder is doing it is that it's not compatible with the way that LangChain wants to do it. Now, what we could do is in the pipeline, we could write custom pre-processing and post-processing functions to try and get it more like the one above. In the end, I decided not to do that, just for the simple reason that I don't think this is going to work that well without fine tuning. So the next step in this would be to basically take it and fine tune it for the actual LangChain way of doing it. And rather than do it with the StarCoder one, I'm going to try it with some of the smaller coding models and see, okay, can we get some decent results out of those doing the same kind of thing? And then if we were to fine tune it, would we be able to get a model that can do the PAL chain and the reasoning inside the PAL chain for this kind of thing? So anyway, not a super successful project, in that it would have been nice if it just worked perfectly out of the box for this. Unfortunately, the way they've set it up looks like it's not very compatible with LangChain. I encourage you to come around and play with the different prompts in here, though, to get a sense that if I make the in-context learning shorter, what will happen? If I make it longer, what will happen? If I try different spaces in there, this is one of the things that can be very frustrating with a lot of these models, is that just putting in a new line character or two can totally change the output. So it can get very frustrating overall for this. Anyway, as always, if you've got any questions, please put them in the comments below. In future videos, I'll look at doing some more coding models. We'll look at doing, something like that, and perhaps even fine tuning one on some kind of data set to get a result that we can maybe use for PAL for this. If you found the video useful, please click like and subscribe. I will talk to you in the next video. Bye for now.